Hi everyone, thanks for joining this session. We're going to talk about smart control plane for CI/CD pipelines. So I'm Shripad Nadgowda. I'm software architect. I'm currently leading multiple initiatives around software supply chain security, primarily around how we operationalize SBOM and how do we secure our CI/CD pipeline. There are a few talks I gave at KubeCon earlier, so you can even look into those. And I'm joined here with Ashish.
Hi, thanks Shripad. My name is Ashish Batwara. I'm technical evangelist, experienced in leading multiple teams and then working around cloud, software, storage, networking, analytics. Played several roles, product management, developer, manager, etc. So, well, let's get going. So I'm going to cover the background about what we are doing, and then Shripad is going to talk about the actual demo. And you will see, how this smart control plane works. So, so let's talk about CI/CDs. Of course, I'm not going to cover CI/CD. CI/CD is not a new topic, right? There are many tools available in the market, like Jenkins or Tecton, that can be used to set up a pipeline, right? And that can automatically trigger the build, the testing, the analysis of the code, or even deployment on the target platform. So our approach basically extends these tools by providing a smart control. That means allowing multiple pipelines and multiple users to be managed by a single control plane. That means you can have complete visibility into different projects depending on your roles and the requirement. By smart, I mean that basically, automated recommendation, considering the projects, considering the user roles, considering several artifacts related to the project. Okay, so before I get going in detail, let's talk about who are our partners in this. So there are several user personas or actors, right, for a CI/CD pipeline. I'm going to cover just 4 of them, but like developers, so the QA engineers, release managers, your InfoSec, security engineers, CISO. All these are the actors or the personas for the CI/CD pipeline. So today I'm going to talk about just 4 major personas. One is the developer. So basically the role of developer is just to build the code and fix the issues. That's pretty much the role of developer is. And here the Jane is the developer, just for the namesake. Rohit is basically a DevOps engineer whose responsibility is to manage and maintain the pipeline. Then comes down to our CISO. He's or her, the Chief Information Security Officer, right? And her responsibility is to make sure that that the required regulatory and compliance standards are met. So the developer basically looks at the initial or engages at the initial stage of the pipeline. The DevOps engineer and CISO, they look at the later stages of the pipeline. And then fourth is important is the Matt, who is the InfoSec engineer. So basically the InfoSec engineer is basically looking at the designing and implementation and even the managing the different security controls, different security tools, right? To make sure that developers and the whole pipeline has the required tools and controls. So after talking about the different personas, right? Let's talk about the different types of CI/CD pipelines that we may have. The one is like your shared pipeline where multiple users are basically using the same pipeline. Then there are pipeline where basically you can have the modular pipeline. In the modular pipeline, you can have customized control depending on the project. And then that's kind of a variation of a shared pipeline. And then you can have the monorepo pipeline where basically you have single repository, but there are multiple projects get built out of the same pipeline. But one thing is common in across these, like the common goals. Whatever the type of pipeline is, they share the common goal, like ensuring the efficiency, high quality and error-free software delivery, ensure security and compliance, and optimize the resource utilization. So no matter what, you will have these common goals. Now, these actors or the personas have to talk to each other, and coordinating and communicating with each other is a complex task. And on top of it, you will have different pipelines, shared pipeline, right? That also creates a complexity. And then on top of it, these coordinated or the tracking these coordinated communication is a challenge. So what we are trying to solve is coming up with an approach that can help addressing these things. And so far, I just talked about the personas, but now talk about the systems involved in this. So this is the kind of a GitHub repository where developers need to access, put their source code, put the fixes, right? Then coming to the DevOps engineer, they also need to put their configurations, pipeline-related configuration, and the tools-related information in the source code. And then the security tools marketplace, where you need to make sure that you have the right security tools for different project types. So that's and that basically information comes into your source code because that allows you to build and then the actual pipeline itself. And then at the end of the pipeline, you get to see all the compliance reports and different other type of artifacts and reports that basically our compliance officer take a look at it and suggest what's happening. So you can think of, one side is the personas, the other side, these are the different systems. And now they have to talk to each other, right? That's a challenge that we are trying to solve here. Okay, so merging these actors and tools, right, is a complex and error-prone task. It's not easy, right? And on top of that, there are multiple pipelines with multiple components and multiple user roles, right? That creates a much more challenging for us to manage. So this is what we are trying to show here, right? So managing and multiple pipelines is very complex and error-prone. Now, so we talked about the tools or the systems. We talked about the personas, right? Now, if I look at from the CISO point of view, right? What are all the what I need from the CISO point of view? I need the insights. I need insights into what type of applications is my organization running, like whether it's a microservices, non-microservices, or Go-based, or the Python-based, right? All these things, information I need to have as a CISO, right? And also, what kind of security controls does all applications that my organization is running, I need to have for that, right? And on the other side, control, like how do I basically, make sure that all these things are running in compliance, and how I make sure that, with all the requirement changes or the new projects coming in, how do I make sure that I have the, I take care of all the requirement changes, right? As requirement changes, I have deployed those tools, make sure that everything is in compliance. Now, talking about the DevOps engineer. So DevOps engineer needs to make sure that it's a ease of maintenance and the automation. When I say ease of maintenance means, how can I efficiently manage and manage, multiple pipelines, right? How do I keep track of the requirement changes? Similarly, on the how do I basically automate these common tasks? And are these strategically defined and managed pipelines really helping us? Because today you can have, each project have their own pipeline, right? They pull in the tools, et cetera, right? Are they really helping us? The one is the developer, right? I want to insulate myself as a developer. I want to insulate myself from everything else, right? I just want to write code, fix bugs, and done with it, right? Nothing more, nothing less, right? How can I basically ensure a high velocity of code deployment? That's as a developer I need to know, right? So now we'll talk about how we are solving that problem, and Shripad will take us through that journey.
Thanks, Ashish. So this was really interesting, right? Like Ashish illustrated. So one problem, as we mentioned, the statically defined pipeline. The pipelines are, today we have so many pipelines. And why? Because they are driven by different parameters. I have a different pipeline when I create a pull request. I have a different pipeline when I commit the change. I have a different pipeline that goes to my production workload, different pipeline for staging. And this is essentially creating this management problem. So when we started looking into this, the solution space, we went to the whiteboard and we said, okay, what do we want? So we thought, okay, we want some magic wand, which actually can create a single control plane where multiple actors can interact through a common system, common platform. What I mean, right? So for instance, as a CISO, when I make a decision that I want to implement a new security control for my organizations from going forward, I make that decision and I communicate or feed that decision to this magic control plane. And now this magic control plane needs to be able to create an actionable plan. Like, okay, who are the actors who are affected by this decision? For instance, I made a decision that I need to implement new security control. So what are the tools that are required for that can implement this? So someone has to discover those. And then the DevOps engineer, they need to go and implement those in the pipeline. So that is essentially the kind of the interactions that we are looking for to automate here. And the second thing is we already have plethora of this system that we just discussed. Like we have, for just storing the source code, we have GitHub, GitLab, Bitbucket. For running our pipelines, we have Jenkins, Tekton. We are not trying to create yet another system, right? This platform is built on top of it. We want all these existing components to be plugged into this system, so we can effectively, basically manage these systems. So this was essentially something that we say, okay, on a high level, this is something that we want, a single control plane that can achieve this goal for us. And then we say, okay, what are the three major principles, right? So one is, we want this common platform where these multiple actors can share responsibility and then they can manage actions. When I make a decision, I don't have to basically explicitly communicate to all the respected or affected parties. I just make that decision and I feed it to the system. It will communicate and manage that, the after effect of that decision. The second is automation with the dynamic decisions for pipeline executions, right? So one thing that, as I mentioned, the one problem that is we have too many pipelines. What if we have zero pipeline? The pipeline gets created when they are needed, right? So I need a pipeline. I look into the context. What is the event that is creating the pipeline? What is the context in which it is being invoked? And I automatically compose the pipeline, right? And that pipeline get used for execution. So we don't have to store and manage and version control the pipelines. The pipeline as a code, maybe we can just get rid of that. And then finally, the pluggable interface, right? As I said, our objective is not to invent yet another system, but to allow a platform where these existing systems, existing technologies that we have, they can be easily plugged in. So this is essentially a few principles that we set forward for us. And then we say, okay, let's go ahead and build this system, how it can look like. So on a very high level, it has two components, right? Pipeline executions and pipeline management. So pipeline executions is anything that is all the components that get involved when you start executing a pipeline. When I create a pull request, the pipeline get executed. So all those things come under the pipeline execution. Pipeline management is the thing that is happening back in the background or out of band that affects or influences the pipeline executions. Like I make a policy, the CISO is making new decision or new tool, some tool is getting deprecated from use. So all those things come under pipeline management that is happening in the background, and they influence the pipeline execution. So what are those components look like? So again, SmartFlow is something that we call this platform, the magic wand that I showed you. So it is based on some set of APIs that we are still expanding. One thing it has a sec tool crawler, right? So what this tool does, it essentially crawls. There are a bunch of marketplace where these tools are available, and these tools are specific, right? When I want to do, let's say, vulnerability scan, I have set of tools in the marketplace like Sneak or others which are the paid versions or some open source like Trivi that I can just use. So the sec crawler tool goes ahead and it crawls the artifact hub, the GitHub marketplace, and all the marketplace where these tools are available, and it find out these tools are applicable for this kind of artifact in this context. These are applicable for container or monolithic applications or microservices, and it creates a catalog internally, right? Then we have policy managers. So our objective was to automate various actions, and when we have actions, we need to have some way to communicate our restrictions, right? So that is a policy manager, and the pipeline configs. So even if when I say the pipelines are getting created dynamically, there are some configurations like if I'm using some proprietary tool for some security scan, I need to feed it some secrets or what are the API endpoints that are common, which are not specific to execution, but basically the configuration of those particular tools that needs to be fed. We have centralized database where all these actions, all these events, all the metadata is stored, and of course the event stream, right? Whenever one component changes, we need to have the via smart flow, which essentially find out what is, oh, this is the action plan, and it communicates the events, like, okay, the developer needs to do this, or these are the things that we need to actuate for that particular persona. And this is all in the management plane, right? This is happening in the background or out of band. And then the execution, which shows the GitHub. As a user, I make some change. We build a trigger handler. So that action doesn't invoke, directly interact with your target CI system like Jenkins or Takedown, right? We have our own trigger handler, which actually intercepts that request. It passes the event. It determines the context, like who is the user, what kind of event is it. Based on all the management that we have done, what kind of pipeline does the user want, what kind of desired controls there are, we dynamically create a pipeline definition, right? And then we start executing that pipeline. So this essentially avoids a lot of overhead in the sense that now as even DevOps engineer, my responsibility is just to ensure that I'm providing a concrete pipeline configurations. I don't have to, if let's say newer version of some source tool are available or some tool is deprecated, I don't have to go and change all thousands of pipelines that are used in my organizations, right? So we are trying to avoid that bottleneck and to drive the efficiency out of it. So let me show you quickly some demo that we have. Again, I'm right now showing it through command prompt. This is again a very active project. So we are building out some UI framework on top of it. So let's say I'm a developer and I register some, I say, okay, smart flow, register this particular repository for me, right? It tells us this is what kind of project is it and what is the role? Is it a sandbox or is it going to in the production? Once this goes, our SmartFlow engine, it basically goes ahead, discovers the various artifacts for this repo. Is it a microservice repo? What kind of artifacts that are being used? And it feeds it into our database. Now, as a developer, that's my role, and that's essentially what is covered here. Now, as a CISO, I go and I say, okay, I want to list the features, all the features that I have defined here. Or I can first actually query the repository, right? So show me all the repositories that are used in my organization, right? It tells us, okay, these are the repositories, these are the artifact type, what kind of applications are these. And again, in typical organization, just seeing this list is not going to be helpful because it easily will run into thousands. Like in our organization, it is like in tens of thousands or close to 100,000 repositories. But then I can go and say, okay, what are the security scans that I have, features that I have defined for my organization to implement, right? So that's my responsibility, that I need to have, if someone is using Go, then they need to have static scan, vulnerability scan, what kind of artifact is it applicable to, and what is the importance? Is it critical, it is important, or it is optional, right? So these are basically the security policies that I'm defining as a CISO. And then I can basically ask, okay, what are the, are there any security policies that I'm missing? I mean, my developers are using some artifact. There are some security policies for that, but I'm not covering those kind of artifact. And now it says, okay, there is some developer is using this data trident library, which has some artifact called mustache, which is related to the storage. It is used in production, but yeah, you don't have any security policies defined for this. Okay? And as a CISO, I can make, okay, this is fine. I think I can make a glass break and I can say, okay, this is approved. I don't have any concerns for this. And we can go ahead and basically go ahead with this. Now, as the InfoSec engineer, now my CISO has defined some policy, my developer is using something. And now, as an InfoSec engineer, I need to know, are there any gaps in the tools that are available in my organization? I say, okay, there is no gaps that are available. And now, suddenly, I have some developer in my organization who decide, okay, Rust is the new shiny thing, and I need to build my new application in Rust, right? So he goes and he registers a new application. Again, this is an application which is built in Rust, it uses Nix, and now CISO is unaware of this, right? CISO doesn't know that there is new artifact or new security controls I need to define. So CISO again goes and, CISO goes and says, okay, again, periodically, our system will create an event. It says, okay, seems to be some artifacts, some applications, like written in Rust, Smarty, that are being used by your developers, which are being deployed in production, but you don't have any security controls defined for this, right? So now, as a CISO, I can say, okay, I need to basically add some security controls. So I say, okay, I'm going to add a security control that all the Rust code should be statically scanned, and it is critical. It has to be done, right? I add this. Now, the smart control is essentially going to create the event for the DevOps, for the InfoSec person. That is, okay, there is a CISO policy defined, but there is no tool that you have defined here. And now, the smartness that we are talking about, right, it comes from, we are not only telling about the gaps, like what is not present. We are actually telling what are the tools that are available, right? So because we have that, I told you that the SEC crawler, which actually crawls and find out what are the applicable tools, maintains the catalog, and now it is tried to recommend the tools to the InfoSec, right? Okay, there is a gap. You don't have some tools for Rust, but there are some tools like Cargo Audit, this particular version. Is it free? What is the license for this? And now as a InfoSec, I can say, okay, I think this is good. I can go ahead and approve this particular tool. And that would essentially go ahead and trigger the workflow for pipeline creation, which we are not showing, I think. We'll talk about it briefly in a minute. But this is essentially the crux, right? I showed you the management workflow, that one I showed, like how we are managing this, the information that is flowing between different actors, how we are automating, what are the smartness that we are baking into the system. So let me go back to the slides here. So what about, so there are a few things that I think everyone is thinking, right? We have been hearing about one pipeline or pipeline templates and everything. So how is it different than that, right? So this one pipeline templates, they basically are trying to standardize the pipeline inside the organizations, right? So instead of, if I have 100 developers, right, and they are building their own pipeline, then I end up with 100 different pipelines with different size and shape. Now with one pipeline or this template, I still have 100 developers, but they are all using 100 pipelines. They are using one pipeline, but I still have the 100 pipelines to manage. The only thing is their shape and size is same. If I want to change something, some configurations or some tool I need to add, I still need to go and update all 100 pipelines, right? So that's the catch here, that it is not that we are saying that everyone should use the same pipeline, but we are saying the pipeline will be created for you when you need it, right? You don't have to manage this. Another, as we saw earlier, when I think Christy was also telling in the keynote today, we have a lot of auto generations, pipeline auto generations being baked into ChatGPT, Bard. We can just say, okay, build me the pipelines, and it will start generating the pipeline definitions for us. So, but again, as we discussed in the keynote, right? So these definitions, we cannot just take it as is. It's like, even if you see in the description, it says this is a starting point, right? So you need to take this, and you need to validate this, and then you need to understand and then put it into use, right? We cannot just directly put it into use. And these are the things that we are currently exploring for the auto generation of the pipelines, and putting it into our frameworks together. So call for actions, again, this is an open source initiative. We want to basically looking for feedback. We are looking for some technical advisors and contributors. We are currently running some pilots for integrations into existing solutions, like how do we integrate with Tecton, how do we integrate with Jenkins, how do we integrate with Marketplace, how do we make them pluggable, and get some feedback from respective vendors and get these things basically in actions. With that, I think, yeah, if you have any thoughts, any feedback, please feel free to connect with us on GitHub or on Twitter. And yeah, I think that's all we had for today. Thank you. Yeah. Do we have my?
The automatic identification of the artifacts from the repositories and then identifying which artifacts you have security policies for and then getting those, finding out which tools you can use to run. I mean, all of that is amazing, but I think you stopped just short of the magical part of the magic, which is just in time pipeline.
Yeah, exactly.
Having the initial thinking or directional thinking about what an approach to that might be, because that to me seems like a non-trivial problem.
Yeah, we started with one implementation. I mean, this is something that we started before ChatGPT, right? We didn't knew that we'll have this tool that can generate the pipeline. What we started with is some templates for GitHub workflows, GitHub actions. We basically created a template and we said, okay, we templatize everything, starting from name, tool, where we pull the secrets and everything. And then once we get that event, we started basically populating those templates. I don't need this stage and everything, because this is a deterministic process, right? How do we build a pipeline? Configuration is automations, right? You just call two APIs, the pipeline gets configured. And that's how essentially we started. And then once we started seeing some promise in, oh, we are getting some starting point. We don't need to go ahead and create this template and maintain this template, because we don't want to go from managing pipeline to managing template, right? No, we don't want to just transition to that. And that's where essentially we are now exploring that. We had one solution of this basically using with templates, which was, again, good because we just have a bunch of templates, like around 20 templates for each different tools, and we can select based on that. So whenever we identify new security controls, the DevOps goes and creates that template, and then at runtime, we automatically select that template and populate it with the values. So I think that approach works for us, and that actually was good for the initial pilot that we did. But I think right now we are, as I said, exploring with some of these AGI features so that, okay, can we build it on top of those starting points that are getting provided. Yeah.
I know you were focused more on the CI piece, but did you guys have some thoughts on how you were going to automatically generate the pipeline for CD? You might have different deployment targets.
Yeah, CD, I think we had a few thoughts on CD deployment also. I mean, the challenge there is the configurations are basically quite diverse there, right? So again, the approach is going to be the same. We need to abstract out the differences. If we can model them in some way, because if I'm deploying on Kubernetes, that is completely different than if I'm deploying it on some server, right?
That depends on the target, basically.
Yeah.
We see a lot is our CI is pretty standard across all of our applications.
Yeah.
CD is different.
CD is
yeah.
different.
Automatically generating pipeline is going to be interesting. It'll be cool to see where you guys go with this.
Yeah, absolutely. Yeah.
So I noticed a bit with the sort of developer registration part of the process that it appears that there's some kind of level of either developer declaring what is in their repo that they're registering, or there's some kind of like auto detection of framework languages that are being used.
Yeah. So right now we have the auto generation. So we don't ask developer to, I mean, developer as a developer, I just say, because one thing is if we put a lot of things on developer, then if they make a mistake, then again, we want to basically, that is basically becomes our baseline, right? Whatever developer define. Instead, if we have a lot of automation, we can discover those. So in this one, I just showed you, when you register, the smart flow goes ahead, discovers, is it a microservice, do you have Docker file?
To follow up on that, is that there seems to be a lot of like similar projects trying to do similar things. I'm thinking like Delpax, for example.
Oh, yeah.
Delpax has detection is like a part of
Yes,
kind of
exactly.
API that they have. We at Red Hat are using Elizer is another project that we have open source, trying to do similar things of like taking a look at the code and trying to make good educated guesses as to what's in there. Is this something where this is either another thing?
No, yeah.
To like help bring these things together?
Exactly, yeah. So idea, again, we want to leverage as much as possible, right? We don't want to reinvent the wheel, right? So build packs essentially, I use it properly, and that is essentially the motivation, right? That, okay, we have this discovery engine that build packs already was doing it. When you give it a repository, it determines how we can build it, right? And for us, we don't want to build it, we just want to get that, extract that knowledge, okay, what this artifact means, right? Build packs was specifically for microservices, right? It says only. So we said, okay, we want to basically go beyond microservices also. Like we want to discover microservice as one artifact type. Like if I Docker file, if I'm building it, then, but there might be some applications which might be beyond. So, but again, we want to build on top of the existing tools and technologies, for sure, yeah.
Thank you.
Yeah, I think that's all. I think we are running out of time. Thanks everyone.
Thank you.